In the last session, we have seen the introduction to the power producing and power absorbing turbo machines. Now we will see in details the power absorbing turbo machine first. The examples are fans, in which air is the working medium. The classification is axial flow fans and radial flow fans. Next is blowers, where air is the working medium and it's again classified as axial flow blowers and radial flow blowers. Propellers and ducted fans have also air is the working medium. Compressors is the type of power absorbing turbo machines. It is classified as reciprocating compressors, rotary compressors, and the rotary compressor is subdivided as axial flow compressors, radial flow, and mixed flow compressors. The last type is pumps, in which water is the working medium. The pumps are classified as reciprocating pumps and rotary pumps. The rotary pumps are again classified as axial flow, radial flow, and mixed flow pumps. Next are power producing turbo machines. The examples are gas turbines, in which air and combustion gas is the working medium. Gas turbines are classified as axial flow gas turbines and radial flow gas turbines. Steam turbine, in which steam is the working medium, and the steam turbine is classified as impulse turbine and reaction turbine. In hydraulic turbine, water is the working medium, and they are again classified as impulse turbine and reaction turbine. The examples of reaction turbines are mixed flow and axial flow. And the last is wind turbine, where air is the working medium. The classification of wind turbine is vertical axis wind turbine and horizontal axis wind turbine. Now we will see the classification of hydraulic machines in equation form. Here there are two types of energy, it is hydraulic energy and mechanical energy, in which the turbine converts the hydraulic energy into the mechanical energy, while the pump converts the mechanical energy into the hydraulic energy. In hydraulic turbine, the hydraulic energy, that is potential energy and kinetic energy, is converted into mechanical energy. Now we will see the classification of the turbines on different bases. First, on the basis of action of water and on the moving blades. These are classified in impulse turbine and reaction turbine. First is impulse turbine, in which the pressure of liquid does not change while flowing through the rotor of the machine. In impulse turbines, pressure change occurs only in the nozzle of the machines. The example of impulse turbine is Pelton wheel turbine. In reaction turbine, the pressure of liquid changes while it flows through the rotor of the machine. The change in fluid velocity and reduction in its pressure causes a reaction on the turbine blades. This is where from the name reaction turbine have been derived. The example of reaction turbines are Francis turbine and the Kaplan turbine. Next is based on the head. The head means elevation difference of the reservoir water level and the dam water level. First is high head turbine, which is having the head above 250 meters. The example of high head turbine is Pelton turbine. Next is medium head turbine, in which the head is in between 60 meters to 250 meters. The example of medium head turbine is Francis turbine. And last is low head turbine, in which the head is below 60-meter height. The example of low head turbine is Kaplan turbine. Next classification is on the basis of specific speed. Now we will see what is specific speed. It is a speed of geometrical similar turbine which would produce unit power under a unit head. It is given by the equation n root p divided by h raised to 5 by 4, where n is the speed of runner in rpm, that is revolution per minute, where p is power developed in kilowatt and h is the net head in meter. The classification is first slow specific speed, where specific speed is in between 9 to 35 rpm. The example of slow speed is Pelton wheel. Next is medium speed, that is specific speed between 50 to 250 rpm. Example is Francis turbine. And the last is high specific speed, where specific speed is between 250 to 850, and the example is Kaplan turbine. Next classification is based on the position of turbine main shaft. It is classified in horizontal shaft, where the shaft is kept horizontally, and the next is vertical shaft. Fifth classification is based on flow through the runner. It is classified as first radial flow, in which inward radial flow and outward radial flow. Second is axial flow. The example of axial flow is Kaplan turbine. Next is mixed flow. The example of mixed flow is Francis turbine. And the last is tangential flow. Pelton turbine is the example of tangential flow.